Alright, so here we have a standard electric time AR2 impulse unit. So this unit here is dated 1962, and I believe this unit is totally original. It's a 2-wire impulse unit. 24 volts DC is the standard voltage. It's got the metal dial in it. This dial is really nice. I tend to like this style. And a newer version of this particular model is what was actually used in my high school and elementary school. So it's cool to own one of these units. Now, unit does have a form of correction protocol, 59th minute correction, and I'll describe that in a moment. So here's the junction box that I constructed for the standard electric time AR2 impulse units. This unit actually uses 24 volts DC for the normal impulses, and it uses 48 volts DC to engage the correction. Now, just a word of caution about these impulse units and wiring these into the Raspberry Pi. What I have found is that, particularly with impulse units that have a large coil in them, the coil also acts as a generator and can backfeed into your relays. If you don't have your relays properly isolated, this can lead to burning out pins on the Raspberry Pi. So the way to solve that is, if you're using these typical blue relays that you use with the Raspberry Pi, what you need to do is power the relay using a separate 5 volts power supply. So with this unit here, I've got the 24 volts, 48 volts, and the 5 volts is a separate power supply for the relay itself, which prevents, by wiring it this way, that prevents any backfeed from reaching the Raspberry Pi on the control pins. So just keep that in mind if you're setting up these types of units. Now, we'll go ahead and demonstrate the unit here. I just got a quick program to just advance the unit to 26 minutes here, so you can see how it operates. Now with these units, when we engage the correction, it goes to the 59th minute. If the clock is on the 26th minute to the 59th minute, it will move forward to the 59th minute. If it's on the 24th minute, counterclockwise to the 0 minute, it'll move backwards to the 59th minute. So I'll show you both ways. I actually found that if it's on the 25th minute, it seems to get stuck, but I'm not sure if that's by design or if the unit is not fully level. I'm not entirely sure. The way that this system works is when you engage the 48 volt pulse, a secondary, it's the same coil, but the coil has actuations on both sides. On one side, that's the side that normally operates for the impulses. When you do the 48 volt pulse, it actuates a movement on the opposite side of the coil. And what happens is the clock moves by gravity. There's a counterweight on the minute hand that brings the clock around to the 58th minute, and then when the 48 volt pulse is de-energized, it moves to the 59th minutes. This is kind of a cool system to watch, so I'll go ahead and demonstrate that here. All right, okay, here we go. Now it's on the 58th minute, and when the pulse de-energizes, it'll move to 59. So that's that. And let me just show you what happens if it's we'll just move it forward 15 minutes. Okay. All right, I'll move it forward 15 minutes. And what'll happen is when we engage the correction this time, it'll go back to 10:59. So it'll move counterclockwise. Okay, and I'll engage the correction. And the correction pulse stays active for 10 seconds. So that's all for this unit for now. I do have a standard electric GRC unit I'm in the process of rebuilding. It looks exactly like this, except it's got the GRC movement. It was actually labeled AR2, so it looks like they actually upgraded it to GRC. So I'm in the process of rebuilding that, waiting for the new motors to come in, and then I'll have a video on that unit. That's all for now. Have a good night.